so ladies and gentlemen, our lesson today is simplifying zero and negative exponents. And so our goal is to understand the properties of a zero exponent. And unfortunately, guys, I'm really not going to be able to explain why zero exponents have that property until Monday. It has to do with division. And the way our book divides things up, we do multiplication, we do zeros and negatives, and then we do division. So on Monday, we'll be able to ease everyone's mind and explain exactly why the zero exponent works the way it does. But then we're also going to look at the properties of negative exponents, because our goal is to never have a negative exponent in any of our final answers. So, how do we do a third table? What's 2 to the 0 power? Did anyone test it on their calculator? What is 2 to the 0? 1. Does anyone agree with Candace? All right. What about 2 to the negative 1? What do we get there? 1 half. All right. 2 to the negative 2. 1 4. And 2 to the negative third. 1 8. All right. What I would like you to do now with your seat partner or the person beside you or behind you, if you don't have a seat partner, is I want you guys to look at this table and see if there's any patterns that you notice, anything you see happening in that table. Take notice.
It went down by like 2, like some multiples.
Multiples of 2. Did anyone notice that I had to do stuff with multiples of 2? That it was dividing by 2 as you went down? Because we have 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. Which is why the 0 doesn't work here, Russell. Let's have some eyes up front. 2 to the 0 cannot be 0 because then our dividing by 2 pattern wouldn't work. But then 1 divided by 2 is what? 1 half. Beautiful pattern. It divides. Now, second hour, I wanted to look at it from bottom up. So they said multiplies by 2. Would that be the same thing if you're going from bottom to top? Yeah. Anything else? Does anyone notice anything else? The reason it divides by 2, ladies and gentlemen, is because these were 2s. If I had 4 here, guess what it would be? 4. Divide by 4. All right, so that's a pattern. But there's another big pattern we're looking for here. Do you guys notice anything about 1 and negative 1 for the exponent? Is there anything about their answers? James?
What I saw is the 2 in power 1 and 2 is in the power 1. One's 2 and one's 1 over 2.
1 over 2. And when you had 2 as the exponent and negative 2 as the exponent, did the same pattern happen there? One was 4 and the next one was 1 over 4. And then did the same thing happen for our powers of 3 and negative 3? We all see that pattern now? What do we call those numbers? 8 and 1 8. 4. Ooh, Miss Nate, say that a little bit louder. Ladies and gentlemen, were the negatives simply reciprocals of each other? Oh, Jake, if I had big gold stars, she'd get a big gold star. That's exactly what it is. Was anyone else saying reciprocals at their seats? Oh, beautiful. Ladies and gentlemen, that is our property of negative exponents. Now, our property for 0 is simply this. Anything to the 0 power is 1. Whether it's negative 1,755,842.97 to the 0 power, it would be 1. Anything to the 0 power 1. And like I said, I'll prove that to you on Monday. So, this is one of my favorite Einstein things, but we're going to jump over that right now. All right, 0 as an exponent. If you have a to the 0 power, it's going to equal 1. And I don't care what a is. If it's raised to the 0 power, it's going to be 1. That same thing now gets applied to our rules from Monday. I can now have a quantity raised to the 0 power, and it's still going to be 1. Justin. Thank you. I keep calling it Monday, just like today was Thursday in one of my other classes. Thank you. So our rules from Wednesday. Now, guys, if you want to apply those rules for Wednesday, and you're going to want to do that for tonight's homework, I would start by applying that 0 exponent to each of these numbers. What's 1 times 0, Alex? Pay attention, please, because that just got recorded. What's 1 times 0? 0. Thank you. So this is 3 to the 0. What's 1 times 0 again? 0. And what's y for 1 times 0? 0. Now, if a to the 0 was 1, that means 3 to the 0 is 1. Nathan, what's x to the 0? 1. And what's y to the 0? 1. And what's 1 times 1 times 1?
1.
Now, ladies and gentlemen, that's some fascinating mathematics there, isn't it? I like the sophistication of recognizing that this quantity, no matter what's inside of here, if the outside exponent is 0, then it has to equal 1. So if you see that and you automatically go to the 1, bravo. If not, will our rule from Wednesday still work to get us to a 1? Absolutely. All right, negative numbers as exponents. To eliminate the negative exponent, because that's our goal. I only want to have positive exponents. To eliminate that negative exponent, you're going to rewrite it as the reciprocal. 1/2 and 2 are reciprocals. I can turn 1/2 into 2 as the reciprocal. Can I make 2 into 1/2, guys? Can they go back and forth as reciprocals? Yeah. So if we take a look at this, a to the negative m is simply written as 1 over a to the m. This moves down to the denominator. So let's take a look at this example. This is what a lot of your problems are going to look like tonight. It's just going to be an expression. And you need to rewrite it so that there's no negative exponents. So, x to the third, I kind of circle or put a box around it. I make it stand out. Because x to the third doesn't need to change at all, does it? It's positive. That's what I want. What needs to change is y to the negative 2 and z to the negative 5th. So if you notice, guys, z ended up in the denominator. That's what we do with our reciprocals. Where did y end up, Russell? Where did the y end up at? The denominator, right? And where did the x stay? In the numerator. It's positive. It doesn't need to move. And that's it. That's all we need to do. Now, they will get more difficult come Monday and next week. Tuesday, of course, pal, that was a grown-up pleasure. I could tell, like, yes, good math. But we will be able to do more challenging things with these. Grace.
So the negatives always on the bottom and the positive on top.
The negatives will always move, is what I like to say. Because could our negatives be in the denominator to start with? Yeah. And so what it means is your negatives will always change position. And this was a really good comment that Grace is making, and I hope you're all catching it. Negatives will always change positions. Positives will stay where they're at. So let's go take a look at some examples. X to the third equals 1 over x to the third. Beautiful. How many people already had that? Woohoo! You guys are so smart. As soon as I see a negative, I know I'm going to have to make a fraction, so I draw my fraction line. You think you got a right answer, Justin?
Yeah.
I challenge you to give it to me.
7 over 8. 7 over 8 and 4.
Does anyone agree with him? All right, I will too. Good job. My positive stayed where it was at. My negative moved down. Example 3 is what I was talking about, guys. They can start with fractions. But because I have this negative in the denominator, it can't stay in the denominator. Where's this negative actually going to move? It's going to move up. Where's this negative going to move? Down. And what's going to happen with b to the third? It's going to stay exactly the way it is. Now, we like to write our variables in alphabetical order. So when I look at my numerator, c is going to be up there, so that means b to the third comes first. C to the fourth is second. And then Nathan, what's in my denominator? A to the second. Do not forget, ladies and gentlemen, you have those ones that you can put in there. Well, I'm going to now take this negative 2 and multiply it by each of the exponents, correct? So I'm going to call this 3 to the negative 2, x to the what? Negative 4. And what's y going to be 2? 8. You can get positive exponents even after multiplying by a negative. So y to the 8th I'm going to circle, and I'm going to put that directly in my numerator. Because it's positive, it doesn't need to move. I'm going to circle these two, and I'm going to move them down. 3 squared x to the 4th, but I heard someone just say the finish to the problem. We have to do the 3 squared. So this should be 9x to the 4th in your denominator, y to the 8th in the numerator. Does that make sense, guys?
Yes.
Beautiful. Are we okay with that? All right. Realize we will make it harder come Monday, so don't worry. Your assignment is problem number 2. Then 15 through 27, multiples of 3. Then 30 through 45 all. Can I just have your attention for one last minute before you move too much? This is Thursday's assignment on your agenda, guys. We did not skip over that. We just moved it to Friday. So if you don't get this written down at the top of your paper, remember to look back at Thursdays.